You are most welcome to this lesson. I am teacher Katimbo, once again, teaching mathematics. So I've come for P4 this time. Again, I've come with a topic started last time, that is length, mass, and capacity. We so much talked about length. Now today, we are looking at mass and capacity. So, of the two, mass and capacity, we are starting with mass. We said mass is how heavy an object is according to our level. And we are going to look at the examples about what we need to know about mass, and being that mass is how heavy an object is, it's then measured in grams. In a unit to do with grams, one will be talking about mass. As the first example suggests, express 5 kilograms as grams. Express 5 kilograms as grams. Still use King Charles' daughter, this time Grace. Where Mary was, we are using Grace. Remember in length, we are using Mary. And now D stands for Grace. Drum called milk. King Henry's daughter, King Henry's daughter, Grace, drank cold milk. Where K alone means kilograms, H, hectograms, then capital D, decagrams, then this D means grams, then small d, that is decigrams, then C means centigrams, and then milligrams. And now we are talking about 2 units, kilograms and grams. So where K is, that's kilograms, write 1, then write zeros up to D. So you have developed a fact that 1 kilogram is equivalent to 1,000 grams. And now you state 1 kilogram is equivalent to 1,000 grams. What about 5 kilograms? That is 5 times 1,000 grams. So you multiply 5 by 1, get 5, then bring down all the 3 zeros to make a 5,000 gram mass. So 5 kilograms are equivalent to 5,000 grams. In that way, one will have learned how to convert from kilograms to grams. Remember King Henry's daughter, Grace, drank cold milk. You'll be able to evolve that fact that a kilogram is equivalent to 1,000 grams. Then go to example number 2, which says express 1.5 kilograms to grams. Express 1.5 kilograms to grams. Once again, we are converting kilograms to grams, only that this is a mixed fraction now. The other one was 5 kilograms, this is a whole. Here I've got a whole and a fraction, which is actually known as a mixed fraction. So express a mixed fractional kilogram to grams. Still right, King Henry's daughter Grace drank cold milk. Then we are interested in kilograms and grams, the K is here and the G is here, which means grams. Write 1 against K and then zeros up to G, so that you have the same fact that 1 kilogram is equivalent to 1,000 grams. What about 1.5 kilograms? You get the same 1.5 times 1,000 grams. You are then going to convert this mixed fraction to an improper fraction by multiplying here, that's down, and here you add. So you get this denominator times the whole number plus numerator out of the denominator. So you get 2 times 1 plus 1 out of 2. So 2 times 1 is a 2, then plus 1 get 3. You get 3 out of 2. So you say 1.5 kilograms is equivalent to 3 out of 2 times 1,000 grams. Before we then divide by 2. 2 divided by 2, you get 1. 10 divided by 2, you get 5. 0 divided by 2, you get 0. And 0 divided by 2, you get 0. Thereby remaining with 3 times 500 grams, where 3 times 5, you get 15. And you see these 2 zeros must be brought down. You get 1,500 grams that are contained in 1.5 kilograms. Please follow the steps. You'll be able to do whatever is brought to you when you convert one unit in mass to another. Then we shall turn to example number 3 today, which tells us to express 9,000 grams as kilograms. Express 9,000 grams as kilograms. As opposed to number 21 that asked you to convert kilograms to grams, number 3 tells us to do or redo it, or to do it the other way around, from grams to kilograms. From grams to kilograms. Still write King Henry's daughter Grace, one called milk. Then write 1 against kilograms, then all the zeros to grams. Then this time round, you state that 1,000 grams make 1 kilogram. 1,000 grams make 1 kilogram. What about 9,000 grams? You get 9,000 divided by 1,000. Answer in kilograms. Like we divided before, we cancel by 10, meaning cancel off the zeros. Wherever the zeros are divided, I repeat, you actually divide by 10. You say by 10 by 10, by 10 by 10, by 10 by 10. You can able to see that 9 remains undivided and 1. So 9 divided by 1, you get 9. So 9,000 kilograms are equivalent. So 9,000 grams are equivalent to 9 kilograms. That way, you have learned how to reverse the grams to kilograms. You then answer in a piece of work about such mass conversion. We go to example number 4 about mass. Tells us to work out the addition of kilograms and grams. That 8 kilograms, 280 grams, plus 1 kilogram, 569 grams. Like we've done before in length, here we are going to add and regroup or carry accordingly, like as usual. We say 8 plus 9 is 17. Or 1 writes 7 and regroups 1. Instead of 17, you write 7 and then regroup 1 or carry 1. Actually regroup. Then that is to the 10th section here. So 1 plus 0 remains 0. Then that's 1 plus 0 is a 1. Then a 1 plus 6 gets 7. 2 plus 5 is also a 7. Then add the kilograms. That is 8 plus 1, you get 9. So the answer is 9 kilograms, 777 grams. So you add normally, like we did in length. Likewise, you can be told to subtract kilograms and grams. Still, you subtract normally. So I've got 9 kilograms, 832 grams, minus 7 kilograms, 412 grams. So still we start from this side. 2 minus 2, you get 0. 3 minus 1 is a 2. 8 minus 4, you get 4. And then 9 minus 2, you get 2. So as easy as that, the answer is 2 kilograms, 420 grams. As easy as that. Then we shall turn to example number 5 about mass. Now, unlike the rest, this one is worded, which is actually in numbers actually feared among the pupils or learners, because when you see worded questions, they tend to just go away or run away without interpretation. Whereas the word questions are the easiest because they explain themselves. Like number 5 reads, a boy had 3,000 grams of maize flour, and his father gave him more 7,000 grams. I repeat, a boy had 3,000 grams of maize flour, and his father gave him more 7,000 grams. Then the question says, express the total mass the boy had in kilograms. Express the total mass the boy had in kilograms. As you know, when you have something and somebody gives you some more, the number you had increases. So because the father gave this boy some more grams, and now has got a lot, we are going to add. So first get the total mass in grams through addition of those two masses of 3,000 and 7,000. So put a heading and say total mass in grams. Remember the boy had 3,000 grams and the father brought other 7,000 grams. So we say 3,000 grams plus 7,000 grams. Remember, put that 0 plus 0 get 0, 0 plus 0 is 0, 0 plus 0 again is 0, so 3 plus 7 is 10. Now the boy altogether had 10,000 grams. But the question tells you to express the total mass the boy had at last in kilograms. So in that way, you are going to convert the total mass in grams to kilograms. So the boy altogether had 10,000 grams. That is what he had at first and what the father actually brought, and added on to what he had at first. In total makes 10,000 grams. Now convert 10,000 grams to kilograms. Still write King Henry's daughter, Grace, gram code milk. That way, we've got a kilogram and gram. So write 1 against K and zeros have to be. In that way, you will know that 1,000 grams make 1 kilogram. What about 10,000 grams altogether? You get 10,000 divided by 1,000. Answer in kilograms. Now start your cancellation. So say by 10 by 10 by 10 by 10 by 10 by 10. Remain 10 kilograms in total. So 10,000 gram mass is equivalent to 10 kilograms. So the boy had 10 kilograms altogether after being given some more grams. So always read the question and answer, because many of you stop at grams because they have had total. Yes, it calls for addition. But the question is saying to express the total mass the boy had altogether in kilograms at last. First get it in grams, remember to convert it to kilograms. So never fear, question is concerning what the questions, that is concerning words. So the questions that have got or contain words are the easiest because they actually help you know what to do. Here the key word was more. So giving you more means addition to what you had. So you add and then later you convert. The examiner asks you to answer in kilograms. Then that's all about mass. Now we go to capacity. As we said, capacity means volume in liters. Volume in liters. So it talks about all liquid or substances like water, like milk, like anything that is a liquid, petrol, any fuel that is. So that is capacity. Whenever you hear capacity, they want you to answer in liters. Now, Here at our level, we learn how to just convert from one unit of capacity to the other, as the examples suggest. So, example number 1 says convert 60 liters to milliliters. Convert 60 liters to milliliters. Still here, one must know King Henry's daughter Lillian. Now Lillian. This time Lillian drank cold milk. King Henry's daughter Lillian drank cold milk. Remember in length, we said Mary. Then in mass, we said Grace. Now we are saying Lillian in capacity. King Henry's daughter Lillian drank cold milk, meaning kiloliters, hectoliters, decaliters, liters, deciliters, centiliters, and milliliters. And now we are concerned with liters and milliliters. So liters are here, this is the L, and these are the milliliters. So write 1 against L, 000 up to milliliters. In that way, we shall know the fact that 1 liter is equivalent to 1,000 milliliters. What about 6 liters? You get 6 times 1,000 milliliters. Where 6 times 1 gets 6. Then draw down those 3 zeros, thereby making a 6,000 milliliter capacity. So 6 liters are equivalent to 6,000 milliliters. As easy as that. And the moment of the fact is where the problem can be created. But when you learn King Henry's daughter Lillian drank cold milk, you will be able to develop any fact about this capacity. And example number 2 tells us to convert now 9,000 milliliters to liters. Remember, number 1 was converting liters to milliliters. Now milliliters to liters. Still right, King Henry's daughter Lillian drank cold milk, and then write 1 against liters. Then write all the zeros all the way to M, that means milliliters. This time round, state that 1,000 milliliters are equivalent to 1 liter. What about 9,000 milliliters? You get 9,000 divided by 1,000, answer in liters, then divide as usual. Divide by 10. By 10, by 10, by 10, by 10, by 10, by 10. It is then seen that 9 liters remain undivided, thereby getting the equivalent of 9,000 milliliters in terms of liters as 9. So 9 liters are actually coming out of the 9,000 milliliter capacity. Then the last example today about capacity is telling us to work out the addition of liters and milliliters. We've got 2 liters, 321 milliliters plus 1 liter, 614 milliliters. As we did in length and mass, we are going to add normally. So go in the place values properly, that this is 1s, 10s, hundreds, whereby among the ones who have got 1 and 4 added, that's 1 plus 4 gets 5, 2 plus 1 gets a 3, 3 plus 6 you get 9. Then on the intersection I've got 2 plus 1, the answer is 3 liters and 935 milliliters. In that way, you will be able to answer the whole topic, which is length, mass, and capacity, and that's all what is needed in P4. About that, you will still find it in P5, 6, and 7, but the way we teach it is actually different from what is done, but this is the foundation of everything. When you understand here, you don't disturb any teacher in the other classes. I am teacher Katimbo Richard that has taught you this. For more information about it and other things about mathematics in general, call teacher Katimbo on 07572 33066. I repeat, 07572 33066. Stay safe.